Hey guys! So, we're looking back at our first target for Key Concept 2. We're still looking at our trigonometric ratios. So, if you remember, last time we were setting up the trig ratios, and then we were solving for sides using those trig ratios. Okay, if we know the angle, we can use the trig ratio to find that missing side. Now what we're going to be doing is finding the missing angle. Right? So it's very similar, but there's a slight difference in how you solve it. So if we look at this example A, right, we're finding the measure of x in each diagram. So again, I'm always going to start by marking that angle, right? That's my angle x. And just like we were doing before, we have to label our opposite side, our adjacent side, and the hypotenuse. So remember, the hypotenuse is always across from that right angle. My adjacent side is next to that right angle. And then I have my opposite side. So here, I know nothing about my adjacent side, right? So I'm not going to use that. I'm going to use the O and H, right? And if we remember, the sine of something, right, and we're looking at angle X, equals O over H. So the sine of X equals O is 6, H is 10. Okay. So now we're solving for X. Think about solving an equation, right? Anytime there's something with X, we always do the opposite, right? If something's being added, we subtract. If something's being multiplied, we divide, right? When you're solving for X, you're always doing the opposite. And sine has an opposite too. It's called the inverse of sine. And it's written as, right, sine with a little -1 next to it. It looks like an exponent. But that -1 really just means inverse. Really, like the opposite. Alright, so that's sine -1 of sine of x. Right, so taking the inverse of that. And on the other side, I'm taking the inverse of 6 over 10. For these inverses of sine, cosine, and tangent, they always have to go in front. They can't go in back. You're not doing inverse sine times 6 over 10. You're taking the inverse sine of 6 over 10. Okay. So here, right, the inverse of sine and sine, those cancel out. They're opposites, right? So I'm left with x equals the inverse sine of 6 over 10. Okay. Once I get here, right, I'm typing that into my calculator. Right, so in my calculator, still under those trig, that trig button, right, that's weird. If you look, I have like sine, cosine, tangent. Underneath them is the inverses, right, with a little -1. So the inverse sine of, and it's 6 over 10. So your x equals 36.87. Degrees, right? This is an angle. So it should be in degrees. And that's it there, right? So we're still just solving for x, but we really do have to be aware of that inverse of our trig function. All right, let's look at example B, right? Same thing, I have my x here. I'm going to label my opposite side, or sorry, start with my hypotenuse. I have my adjacent side and my opposite side, right? So in this one, I'm not using my opposite side. I am just using my adjacent and my hypotenuse. So that leaves us with cosine of x equals a over h, right? So cosine of x equals, my adjacent side is 15, and my hypotenuse is 20. So just like we did with sine, if I have the cosine of x, I'm going to take the inverse cosine of the cosine of x. I'm going to take the inverse cosine of 15 over 20. So, inverse cosine and cosine, right, those are opposites, so they cancel out. I'm left with x equals the inverse cosine of 15 over 20. So then x equals, again, we'll put this in our calculator under trig. I have the inverse cosine of over 20. And I get 41.4096. Let me write that better. 41.41, we'll say. Alright, and that is our answer, and that's all there is to solving for angles. And that's as much as we're doing today in this video. So I'll see you guys tomorrow.